Hey everyone. So another fast API documentation video, another day. Well, I should have said that the other way around, so whatever. Um, so we're just gonna pick up where we went from yesterday, where we were continuing along with async await. That's the page we went through yesterday. Um, I had terrible sleep last night and had to wake up relatively early today, considering how late I slept. So I was not too great. So spoiler alert, I'm tired again. And but I read up to query parameters and string validations. Um, and honestly, like if you know even a little bit about APIs, everything we're gonna go over in this video is super straightforward. Um, but I do just generically want to highlight how good the fast API docs are. Again, it's super good. Like I have barely had to go outside of the fast API ecosystem to Google and figure out things. Something maybe slightly unrelated, like I looked up whether PyODBC can be done async, because I know the PyODBC drivers I used to use did not, but apparently there is a another PyODBC library called AsyncODBC. I don't know. This is just like AI genetics. It's could just be complete library. But yeah, PySync PyODBC does not have sync. It's just gonna have multiple awaits in an async function. That was just something like I sat down and hey, that makes sense, right? Why can't I have multiple await steps within an async down? This is a milestone. Uh, uh, Another thing that did get to me, and I'll get to that, and we'll get to this chat section. We'll get to the magic. We'll get to the magic. Okay, it's not super confusing or anything of a big deal, but yeah, fast API docs good. Not just for learning fast API, but for learning APIs. So, um, environment variables. This is, I think, the second last one before the tutorial for Fast API itself kicks in, and is the similarly second last, like more general purpose pages here before getting into the user guide. Um, so what are environment variables? They're essentially variables that are defined in your environment, and whatever your script is picks up those variables from the environment. Um, mm, so how do I explain that? So for example, if there's a variable called x and you set that to 5, that variable is within the scope of the running Python script, right? Or any script with this x equals 5. That's actually literally valid in almost every language, I think. Um, I don't know, that's just universal, that assignment, right? Um, so if in that same script you say x equals some variable, let's say big X. Let's just say big X because I don't want to use a real environment variable for the sake of the actual description. Um, and big X can be found in the scope of whatever called me. So usually the shell, the terminal, whatever. That's where I'm gonna get this variable from. So in Python, I think I forget env. Yeah, that's I think it's os.getEnv, right? And then you just give it whatever the name is of that environment variable, and you can get it in terms of how you define an environment variable. I know in Linux and Unix, so therefore Mac, also it's just export equals whatever export name of the variable equals value, right? It's pretty straightforward. Um, say export my name, and then you can do hello dollar my name. So this is hello Wade Wilson, and if I was to uh, create like a Python script from this bash um, terminal session, like there's some script that I want to run, and in that script I search for the environment variable my underscore name. I'll get Wade Wilson inside my script. That's essentially what an environment variable is. It's a little unnecessary amount of detail for environment variables, but I'm like, hey, if I'm just gonna do a video series of essentially reading the fast API docs, I might as well just go into detail for whoever wants to review these. Should probably create different playlists from my content, but it's a different story. Uh, so reading the environment variables in Python. Um, so yeah, os.getENV. I guess I didn't even need tutorials. Like, how do you get that? Well, that's as simple as that. Can be used outside the code, but can be read by the code and don't have to be stored committed to Git with the rest of the files. It's common to use them for configuration or settings. Yes, that's essentially usually what environment variables end up being. That or like maybe some way of passing secrets at deployment. That's another way environment variables are commonly used. Um, you can also create environment only for a specific, only available to that program and only for created right before the program itself. Uh, well, it's still I wouldn't say it's specifically for that program invocation. It's just you create it in that terminal session, and then it's available for that program invocation, but then the program exits, the variable still persists in that session. Types of validation. These can only handle text strings. That's true. Basically, even if you set some variable equals one, it'll just be a string. Um, and hmm, serious array right now over here, but whatever. Some variable equals 2, and if you do os.get in, it will just be a string, be evaluated as the number 2. Or maybe there's some smart validation on get env, but basically just like request responses in JSON, it's all strings, it's all text, essentially. Um, um, so the path environment variable is a special one. Uh, you must have heard of it. It's essentially something that looks like this, or in Windows looks like this, and it's basically a variable that your computer uses whenever you start a program, right? Like literally whenever you start a program, it starts checking these paths, these file paths. Colon is like the separator between the different places to look for running that program. Even if you're like on Windows or whatever and you're clicking a shortcut on your computer, it's in the background that shortcut is triggering a search across these path variables, right? And that's extremely important for virtual environments, which is I think what we're getting to next, wherein your path is temporarily shifted up so that a particular version of packages or Python is searched first, right? Because this path colon is the separator for Linux, so each one is a separate path over here, and for Windows it's set colon like over here, and basically it's gonna search through all these paths to find it, and in virtual environments you're essentially temporarily manipulating this so that it looks in a particular place first where your version, your environment essentially exists when launching a program locally, I mean. Um, and all of this from some of the UV stuff we were doing. You must know that UV does a fantastic job of managing this itself. Um, but if you're doing pip, you can just do, I think it's pip env dash m something like that. I think it's going to come somewhere. Song Python updating the path. I'm kidding you, that's pretty straightforward, and that's basically the end of it. So that's environment variables. Pretty straightforward. Both virtual environments. That's also pretty straightforward. Inside of a directory, there's you can create a project, you can create a virtual environment. That's okay right there. Python bnb.bnb. That just creates a virtual environment for Python. Now Asterisk, I would still prefer using UV because UV can manage the Python installation as well. So your virtual environment can't won't well, your project management won't just be about the virtual environment, which ends up being packages. But you can also kind of take one level higher that and also be like use this specific version of Python to unlock everything, including the version of Python, which is one of the few things you can't do with most tools except for Conda. Except Conda is just it's not good, man. I do not like Conda anymore. And this coming from someone who started their career with almost exclusively using Conda because it's how you got like the science channels, like the ML stuff, like easily loaded up. That changed very drastically later on, and I think at this point it's just filled with bloat. And most of the Conda channels, whatever, it's managed like by Anaconda by a small team. It's not like this public thing like PyPy is, where it's much more rigorous in its dependency resolution and all that. Because it's so large and so publicly used, unlike Anaconda, which is, I think, mostly crowd favorite. I almost don't know anyone who still uses Anaconda anymore. So you can activate this environment, which essentially just appends to your path variable temporarily, and then when you deactivate, just deactivates. And you can use this which command. I don't know what the Windows, okay, so it's get dash command. Okay. That's how you're doing Windows PowerShell, but in Linux, Unix, which is what I mostly use. And honestly, if you even if you are on Windows, I would just strongly recommend using like something like WSL, like Windows Subsystem for Linux. Um, to honestly just switching to a Unix-based environment. Like if you have a Windows laptop and you are a developer, just make your life easier and swap to Ubuntu or something like that. I personally believe it's just a better solution unless you're working with some older versions of .NET where it's literally not possible. Because all the newer versions, it's fine. Like with the newer versions, like .NET runs on ARM as well, but the older stuff is like finicky. Oh, so this is about upgrading pip. If you use UV, you would use it to install things instead of pip, so you don't need to upgrade pip. But this is generically a big thing where pip upgrades it needs to upgrade itself, and it can cause like package resolution issues. So it's a good step to just do in general inside of a virtual environment. In sort of every virtual environment, if you are using pip as your package manager, which I think at this point better to use UV. Like I went through it, it's pretty simple, it's straightforward, it's better, has better project management baked into it, like throughout the process. And if you decide to start building and publishing packages as well, that's also built in. So like, I don't know, I don't see the point to using anything else. So like git ignore. This one I'll just go into. It's a nice file to have. So essentially, what it is, it's a file that Git which is a source code management tool or and versioning tool. Um, you can, if you've probably heard of GitHub if you are even slightly a developer, which I bet most people watching my content right now is at least somewhat in that process. Because I don't think I speak to someone who's like literally you don't know anything, but still. Git ignore is a nice one, especially if you're coming from a perspective where a lot of DS, and I think this is less and less true as time goes on, but there's still, I think, a significant amount of data scientists who are not like tech enough to know what Git is, what GitHub is. Git is a SCM tool, and GitHub is a Git server essentially. And there's Jira's Bitbucket, there's others, and then there's companies will self-host their own repositories as well, where their code is hosted. Um, and git ignore is essentially a file that says, hey, ignore, like, in this file, whatever path or file names are listed, ignore them. Don't like add them to source code management and version it and track it or whatever, no matter what, right? So why would you want to do that? Because there's going to be, like, if you create a virtual environment .venv, for example, is going to be a directory that is just like, don't need to track that, right? That's just like all the installed packages. Like, someone can recreate it that straight from the PyProject toml or perhaps even vlog. Um, and you can get, what's the word I'm looking for? With um and then another big one is Dunder, PyCache Dunder. I think that Dunder's double underscore, by the way. That one's a little trickier to explain. It's basically has to do with Python. So a common misconception is that Python is an interpreted language. It's not purely interpreted. It's more similar to like the Java just-in-time compilation thing. In fact, you know what? I've said that so many times because they are similar, but let's see if they are. How similar are they? Is Java JIT the same, similar to Python compilation? Because Python is essentially compiled. See, the source to bytecode step. That's why I said it was just in time. Java source code is first compile platform independent bytecode. That's like essentially your cache. Static ahead of time compilation step. When the JVM executes, the JIT compiler within the JVM dramatically translates frequently executed bytecode dynamically. Sorry, not dramatically. But why would it be dramatic? I was so confused. I'm like, okay. Machine code is that Python source code .pyc files before execution. This compilation happens implicitly when a Python script is run, or explicitly if bytecode is cached. Interpretation, the CPython interpreter then executes this bytecode line by line. Unlike Java's JIT, the standard Python interpreter does not perform a... Yeah, okay, that's correct. So the bytecode is compiled from your code, and then that bytecode is then interpreted line by line. So in that way, they're similar. There's that's why I was thinking of the similarity. Is there's that step of going to the bytecode. Um, versus like the full JIT compilation. Um, anyways, so I'm not gonna keep going into what git ignores are, installing packages, pip install, whatever, or UV add, whatever, which is definitely the thing I recommend to do. Running, you just do Python, name the script, configure your editor. What's this about? You probably use dynamic fair configure your sim. Okay, yeah, that's pretty straightforward to do in like VS Code. You just do Command Shift P or Control Shift P, and then you can just like right there first up top Python create environment. Just because it's like the first thing I do whenever I create a new project, and I highly suggest you do the same. Um, now, so yeah, this is a big point wherein essentially if you just use pip to install without using a virtual environment. UV, I think it's fine. I think UV already makes its own virtual environment, but at least this makes sense to me, right? Um, I wonder if ls. I'm gonna. I was about to say. Let me just finish what I was saying. I don't know if UV, when you do UV add, it implicitly creates a project for you if you're in a directory without like a project. Um, that's what I want to test. Make their oh, make their test. BD test. BD test. UV add. Let's just say reach us cd data us cat pie project. Yeah. Okay, what if cd data us enter test cd test us UV add rich. Ah, there you go. Found in current directory identifier. Okay, so it won't just allow you to do that. So just use UV add. uh, so this solves this problem too. But this is essentially the problem with environment managers and UV and all this stuff's coming because the traditional pip just installs to your global Python installation, which can get really bad if when you're dealing with like multiple different projects with different dependencies and things like that. And if there's a dependency conflict, oh my God, it's just hell. That's why package managers and project management CLI tools exist. That's why you have NPM and UV and like NPX, I think. There's many. There's many out there. Um, So that's like essentially what it is. And here's an example of like essentially dependency conflicts, wherein if you have two different projects that, for example, rely on the same package, and you're trying to work on both of them, or you're either just not it's gonna and they both rely on the same package but different versions, that it's just gonna keep uninstalling and reinstalling, uninstalling, reinstalling, and eventually like, or it'll just break, you know. Um, and that's just like not a fun place to be in. So that's really the issue. So faster also down with files up. Try to hold those files and put them in a directory. And by default, put those files down and extract in the directory that comes with your Python installation. That's the global environment. Yep. Um. Uh. Virtual. A virtual directory very similar to the global one, where you can install the package for a project. This way, each project will have when you activate, for example, with like source.b and then activate, can some environment variables will be available for the that will be available for the next one of those variables is the path variable. There you go. Activating a virtual environment adds its path.v and v/bin to the path environment variable. That's basically it. And then when you deactivate, it takes it off. It's essentially what virtual. I don't think it's just that. I bet there's other things it does as well. That's essentially what it does. You know, and that's important. Why do that? Virtual. Um, why deactivate and activate? It's pretty simple. Um, like because you don't want to switch products. That's why you activate and deactivate. Simple guide to get you started and teach you everything that works underneath. Package dependencies. Because they're just shilling for UV again, which I agree with that concept. It's just like better in every way. If you want to learn Python today, forget about it. Learn UV. and UV's not hard to learn. It's a pretty, it's way mature. It's so fast, and it's speed thing doesn't matter that much, especially if you're a noob and you're not like deploying like in production. But it just like makes a nice user experience and reduces the friction between, you know, getting some what's the word I'm looking for, your boilerplate out of the way, the stuff you need to actually writing code. You know, it's like doing food prep. Essentially, it just makes food prep easier. The food prep of coding, I guess. Um, so in the user guide, uh, there's some. Okay, let's go straight into the first steps. I think first steps is just simply to install it, right? Um, is that gonna be the first step it says? No, it's just telling me, okay, so here's a very simple fast API app. Um, they're gonna get into this in this page and the following pages as well. But essentially, you import this, you create an instance of the fast API class with app, which is what's the word I'm looking for? Um, it's instantiated once. And it from there on is like the essential entry point for all of your routes and API endpoint stuff at app.get. So in REST APIs, you have get, put, post, delete, a few others. I think there's patch. I don't know what patch does, but there's norms associated with them and all of that. And at app.get is how you describe uh what type of operator it's a get or a put or a delete or a patch or whatever. And then this is the actual URL for your endpoint, right? So it's just root here. So async def root, return message, hello world. Hello. So basically, essentially, when you go to the root of your endpoint, which is literally just forward slash, that's the root directory in not just an APS, that's just like a file system thing, and it applies here because API is also very, we use URIs and URLs, but they're also paths essentially. And you can run it with um where is it? Copy that on the live server. Oh, there you go. Fast API def main.py. I think the thing they don't explain here, and I actually haven't seen them explored up till where I have read, which is not usually far. I just read it here, and I'll probably stop around query parameters, and I won't go all the way there. Um, is actually I'll probably do request body that because that brings me to this chat very quickly. Um, is that dev launches the dev version of Fast API. So you can have like maybe slightly different dependencies, or you can set up a configuration to use uh, different set of API keys that are tied to things in different cloud environments you have. So you might have like a development cloud environment. You might have like a staging cloud environment. You can have multiple cloud environments with other services that are already hosted. And if your script that you're developing interacts with those, so when you're running the dev version, it'll be interacting with the dev stuff, and then the. So there's many things you can do with the dev. So that's what that bit's about. Um, Runs up the server. You can go here. UVcorn is running here. So there's a couple of different backends. UVcorn is one of the backends, and then Gunnycorn, which is essentially UVcorn, and then UVcorn is the same like app as the same UVcorn backend is like spawned multiple times. That's what Gunnycorn does. At least that's what I remember. I don't remember too well how UVcorn works. I think I have maybe a ChatGPT chat about it. Wait, let me think. Tell me APS for kids activities. Kids activity. Oh, I don't know. And I googled that project overview or something. Fast API backend options. Yeah. So async, multi-process, mess for dev, small prod apps, and then Gunnycorn plus Unicorn, just a common thing. Does this is like production quality because the multi-process thing allows you to deploy multiple instances, right? Hypercorn I don't know what HTTP2 and full ASCII really means. Feature rich. I really don't know what that means. Daphne, WebSocket, Heavy App. These are all different ones. I don't really know about them, honestly. Um, what's Docker slash Kubernetes option? I should read through this chat. Ugh, but I don't want to do that right now. Let's stick to the point. For today, I know that's not what I usually say. I do want to get distracted and stuff like that. And I do definitely urge you to do the same. Like, I really do. And I would as well, but I want to do this video and go sleep. So we're gonna, and I also don't want it to be utter meandering trash like I do. Like I not yesterday, but I think the 2 days prior to that, I feel like it was particularly bad in terms of how rambly I got. So I'm gonna course correct from that. And you should open the browser, go to this, and you'll see at root, see this basically. Boom. It's pretty straightforward. And then you can go to, you can add the word slash docs, and you'll get the Swagger, which is essentially interactive API documentation. You'll get your endpoint. Um, okay, so the items ID is like one of the endpoints they describe and uses examples in this page and a few later pages, and there's also Redoc. I don't really know what the difference is between Redoc and Swagger. I mean, they're just clearly different interactive API documentations. They're both essentially powered by the fact that Fast API generates the open API schema for your API on its own, and because this open API JSON schema is created, that allows for these interactive API documentations to function essentially. So it's really nice. Schema might also refer. Hey, I don't like data schema. I prefer. Oh, actually, no. Data schema is. I do prefer that in this context. Anyways, because I was going to talk about data schema and shape because I think that was in the Python types intro. Um, check the openapi.json. It just shows you that. You can just go to wherever your server is running locally. Usually, if you just ran the function above, and then you do OpenAPI JSON. You just see the OpenAPI thing for recap step by step. Import fast API. Create a fast API instance. Here, the app variable will be an instance of the class fast API. Create a path operation. So this is, I think, the first time in the docs they formalize what a path operation function is, which yeah, I I kind of intuitively think I knew what it is, what they were saying, but it was nice to have this formal definition. So create a path operation is essentially like you have a path, the URL, the URI, and the operation is so the get, put, post, delete, and mm, a path operation function is like literally the function operator with a path and an operation. That's it. Um, it's pretty much all there is to this. And this is how I mentioned this earlier, is how you actually use all of those different operations. Um, function is the function below the decorator. So this little at symbol is essentially a decorator. And what that tells Python is, hey, this thing is a function. I want you to take this function, put it into this function. That'll give me some output, and then I want to run that function, right? That's essentially what decorators are in Python. Is there some other function in this library fast API or specifically within this instance of the class of fast API that I can use called app.get? It takes one parameter, which is the path, and then that this function takes this function and does something with it that allows it to be exposed as an endpoint. I don't know what that is, but that's essentially what decorators are and what they do. And so that's what's up with this apt syntax. And yeah, it's pretty straightforward for first step. So path parameters, essentially, if you are passing a parameter in the URL itself, that's a path parameter. It's pretty simple. Um, and because this whole thing is considered a path, that's why it's called a path parameter. Um, and you do that like with normal F string notation, except you don't even have to say F. You just put the little curly braces, and Fast API just kind of gets it from there. Ah, um, so this path parameter will pass this function. Pretty straightforward. So path parameters with types. So this is where things get interesting. If you do this, it is actually validated and coerced if needed at runtime. So if I receive an endpoint here, like normally type annotations does nothing in Python, but in Fast API, I think they've engineered the framework where it uses that to actually validate and do things with the annotations that you're doing. So here in this instance, what it's saying, because we went through Python types, the item ID will be of type int. So if you put in item slash like 300, this will work and it'll say item ID 300. Pretty straightforward, right? But since it's specifically defined to be an int, if you put in like an obvious thing like some string like hello item slash hello, this will just throw an error. Or if you even put a numeric type that's not an integer like a float, so if you put 4.5, right, that will also throw an error, and the good thing about Fast API is it's a fairly robust with this kind of errors and describes it really well. So whoever is calling it has like an easy way to be like, oh, that's where I fucked up, right? Um, and that's essentially what this little piece about data validation and everything is saying. Use and also like when you do this, it just adds it to the interactive API documentation to basically take that information in when generating the OpenAPI.json, the schema, which powers the interactive API documentation, which is why it pops up in the interactive API documentation as well. Standard space benefits, this is saying exactly what I said about it updating OpenAPI, and that's why Redoc and Swagger both work out of the box here, and any other interactive API documentation that you kind of want to use. Um, Under the hood, all the data validation is performed by Pydantic. I might do a deep dive into Pydantic's documentation or things like that, but I think once I'm done with Fast API documentation, even though I do want to actually kind of go through the Pydantic documentation, like I feel like it would be good for me to learn. Um, Maybe, maybe not. I just like I really need to get to building. And the only reason I'm bothering to just go through the documentation here with Fast API is it's been really good about describing all the pieces to develop like an API like properly, right? There's I think pieces about cookies and about how you do security, um cross-origin resource sharing, like all kinds of really advanced, and and this is before you even get into the advanced user guide, which has even more which has even more stuff. So everything is really well detailed here. And I'm gonna need to use most, if not all of these in the kind of thing I'm building. Compared to in my past, like I have mm, built APIs using Fast API before, but it's been simple stuff for like in-house tools or in-house apps, like things that are meant to be used by like 20, 30 employees. Didn't need to like stand the test of time. So they were simple things. So an interesting thing is that order matters, essentially the order in which you define the functions, because the I don't know. I don't know why exactly. I think it's potentially just a follower from how Python works, because Python's an interpreted language essentially. Is that uh the paths ordering in terms of where you write the functions matter. So user slash me should come before user slash user ID. So for example, an endpoint that's like tell me about myself versus tell me about some guy, right? Um, you need to define this before this, because if you do it the other way around and you send user slash me, it could, because this is the first one that comes up, like in the hypothetical situation where this was above this, it would just like enter this, presuming that ME is some input of type user ID, right? Instead of going to check the next one. Even though it says user ID, or even if this wasn't user ID string, say it was an integer or something, it would still do that and just throw an error and move on with its life. It wouldn't stop. It wouldn't stop to go check the next one. So yeah, you got to be a little bit careful about that kind of stuff. And so, like, in for example, in this situation, this second users will just never be used. It'll always be this first one. So, such is life. Predefined values. If you have a path operation that receives a path parameter, but you want the possible path parameter values to be predefined, you can use a standard Python enum. Yeah, it's just like a common data type thing in like CS enum for doing exactly this. So I can just import enum from enum and do this, create my enum, and then I can pass that enum as a type. So pretty straightforward. The reason you do string, you inherit from both string and enum because the string part helps in developing that OpenAPI .json, like the OpenAPI JSON schema. So yeah, that's what this does. Right, it says that all the values of this enum are a string. I don't know what would be the case if you're having an enum with mixed types, but at this point in time, I don't understand why you would have an enum with mixed types. That doesn't like dive with what an enum does, but maybe I could be wrong. I could be wrong. I don't know. There could be some esoteric things that I'm not really thinking through because I haven't used enums much, to be honest. And these are just the different ways you can access an enum: model name.alexnet, model name.value, and I can just return model name. Um, hmm. I wonder if model name would return the value if I put it like this, or hmm. You know what? I will get to that at some point. I will check my Trello. I'll do that later. You declare a path parameter. I just went through all this. I'm not gonna go through all this. Uh, get the enumeration value is just describing the different ways, like I just said. Return enum members from an even nested in JSON example addict. They'll be converted to their corresponding value strings in this case before returning them to the client. Ah, okay. So never mind. I was like thinking, like, should I test this out in code? Like, should I just copy this and test it? And I'm like, okay, there you go. That's my answer. Because I was in, since I'm passing in model name, would it say, like, in this case, like Lynette or whatever, or LENet? I don't know how that's pronounced. I know ResNet and Alex. I don't know how this is pronounced actually. Lynette, I guess. Lynette. Make it French. Um, so you can have LENET. It will be parsed when it's actually returned. It will be returned as LENET, not as Lenet colon Lenet, even though you haven't said model underscore name dot value. So that's pretty straightforward. So this one's an interesting thing. Path parameters that contain other paths. So that can cause like confusion. So you have to be careful with doing that because of the ordering thing from earlier. Um, but even though this is not strictly supported in OpenAPI, FastAPI does allow you to do that by just pending colon path, right? And you do that in the actual path that you give to the decorator, not in the type annotations. And type annotations, you just do a string. And apparently this is a feature from Starlet somehow, which I think Starlet's all about async stuff. I'm not sure what Starlet is about. I'm just gonna Google that. Oh, Starlet.io. Lightweight ASCII framework toolkit, which is ideal for building async web services. Yeah, okay, there you go. So onto query parameters. Query parameters, we have my first major question, confusion, whatever you want to call it, which is query parameters are essentially like here if I have app.get and I don't define path parameters and I define parameters like in the as function arguments uh, in terms of API stuff, that's considered a query parameter. So this one was a bit confusing to me, not in terms of this, because this is essentially what a query parameter looks like. So a path parameter, like with item ID, whatever, it would have been item underscore ID slash 123, like from that previous example, right? So basically, whenever you're done with the path, you do question mark, and then you start separating, and then you have all the query parameters, blank, ampersand, blank, ampersand, blank. Now, this page goes into uh, I'll get into why that's a problem later. Let me get to request bodies before I get to that. I'll just go over what's on this page because there's some neat stuff, but it's basically about like validation and things like that. Like, okay, how do you define the type? The type annotation here is like the stir, union, or none. Uh, this particular thing is how you define that something is optional. And you can say stir or none equals none. Um, Basically you're saying q can be none, and as default it is none. So if someone doesn't provide q, that's fine. And basically if you set any sort of default values for any of these parameters, path or otherwise, it'll automatically um, become optional, right? So for example, if I just did stir or none without equal none, then Q would be a required parameter. It's just that parameter. It could literally be the word none, and that's fine. Not the word none, but can be the none type, data type, and that's okay. That's like fine. That's acceptable, right? It's just so it's weird. And if you did stir or none equals, I don't know, the string 5,000. Let's I don't know. Let's just say that. I don't know how else to put it. Um, that would be um that'd be fine, and then the default value would be 5,000. So, or it'd just be weird to like be like, this is an optional value and it can be none, but the default value is not none. I don't know, that's just confusing to me, but I can, there's probably a use case for it. So that's essentially it. They go into like a lot of detail, like talking about all the possible options, about how to set a default value, um, etc., etc., versus an optional value, what it looks like, and the URI. The fact that you can conjoin this, you can have multiple path and query parameters, no problem. Um, to make a required query parameter, you just don't provide a default value. So just make it optional so that the default is none. When you declare a default value for non-path parameters, for now we have only seen query, then it is not required. It's as simple as that. So just don't define a default value no matter what. And it'll be a required parameter. It's pretty straightforward. That's all there is to query parameters like this web page. I just wanted to talk about like how you did the stir or none equals none. Now we move into request bodies. So request bodies brings in Pydantic. So Pydantic is, let's just open up this page. I'll try and read from Pydantic directly. It's a data validation library. There you go. And that's essentially what it is. And Pydantic really powers like the request response, like the data uh transferring the request and body stuff in Fast API. I'm sure it does a lot of other stuff, not just that. So that from Pydantic you can import base model, so class item base model. And then, so this essentially defines the schema of a request object or a response object, whatever. In this particular example, it's the request object because it goes into the function parameters, right? And when you do it like this, it updates the Open API schema as well. And the same stuff from earlier regarding types applies here, typing, default values, etc. Everything we said earlier in the query parameters section applies here as well. So it's pretty straightforward on that. Validate the data, give the received data, and all everything is validated in Fast API because of this Pydantic stuff as well. And it'll just throw an error if the data isn't valid or whatever, and it'll give a really nice error because of that as well. And here the docs are automatically updated because it keeps the OpenAPI.json updated, etc., etc. Editor support. I mean, just type annotations in general make really good editor support. Is there anything here that we build around that? Yeah. Okay. Request bodies plus path parameters. Yep. Okay. Request body plus path plus query parameters. Okay. Yeah, you can do that. Yeah. It's just saying that you can do all of these, which is makes sense. So I'm not gonna go to the next one because that's the one where I'm like about halfway through the next one. I wish I'd read more today, but like I said, I was super exhausted, so I was like really pushing myself on, moving really slowly today. But still, I'm happy. That's life. That's what it is. Holy shit, it's 3:30 almost. This, anyways, now that we're done with bodies, I'm gonna come back to my problem over here, which was, I'm just gonna scroll right to the top, right here. Difference between path parameters, square parameters, and request bodies and APS. Okay, so this actually doesn't bring up a problem, and I should have asked the actual question rather than doing this because this just gave me a difference as to what they are, and I fucking know what they are. It's not like that difficult, but and what is a little bit nuanced is like the situations you use them in. Like for example, you just almost never use like some sort of body for the request or the response object. um if you are um if it's like a get, right? Get is basically exclusively path and query parameters. um so but my confusion was like, okay, so the body is full of like key value pairs. Why do we have this separate conception of query parameters, which are also just key value pairs, right? Except for the fact that that goes in the URL versus the other one is sent through a JSON body. Output sensitive to large data and query params or path they appear in logs and for which resource reference for since only both query and body input service I keep people. Um and that's what I basically follow up with. It's like what's the difference? And this is where it really gets into. So there's an aspect of it that semantics and conventions is like, and this is something that's actually supported by Fast API, but I actually kind of wish it wasn't, because it can cause issues because there's a lot of integrations where this is not the case, in that the get operation is almost never associated with a request body, right? It's all just URL and it's just path and query parameters, which is fine. It's totally fine, right? um it's just by convention, and if you do need a body for it to function, all that, it just won't work because there's certain in certain cases, because there's certain frameworks that people are using or certain intermediaries that just don't support that. They just were like, no, that's not how this is supposed to be, which is honestly a little unreasonably opinionated in my opinion, but for some reason socially we've all accepted this for some reason. So idempotency are supposed to be safe, and idempotent and server slash client slash proxies accept that meaningful parameters for retrieval live in the URL. Many intermediaries ignore drop bodies on get, relying on a body for a fetch filter would break compatibility and caching. Query parameters are part of the resources UI. Request body is payload about something, typically used to create or modify a resource. It isn't part of identifying or querying the resource, like it is with the get, right? So this is like a just conventions thing, What exactly? I know item potency. It's like it's the operation is itself, but I'm just gonna Google that. In the context of means that an operation can be applied multiple times without changing the result beyond the initial application. Um, yeah. So it's true. I don't understand why get would be item potent. I mean, can be, but like for example, you request some resource and then at some future date that resource is updated, then the get changes, right? Um, so like I don't know where that line is for item potency, but I think there's I get the point. I get the point here. So this is the really interesting one as to why people don't do this. Is like for caching, bookmarking, and sharing. If you can just cache like like a URL and that's it. That's all you need for a get, which is a lot of requests actually. Like everything on YouTube's a get technically. Right? Everything you click is like get this, get that. I want to click. I want to watch that. I want to watch that. You're not modifying anything, not unless you leave a comment or a like or a subscribe or whatever. Hint, hint, please, guys. um, that's just that's just gonna be the name of this video. Please like and subscribe. That's gonna be a funny one. Um, is that's a big one, right? Allowing for caching of that or bookmarking and sharing. So that's like replayed easily in logs or browsers. These are all big things. That's an important one. Routing and infrastructure web frameworks and reverse proxy // dispatch based on pathless query. Query params are readily available without parsing a body, which simplifies middleware logging, analytics, and limiting logic for reads. Access logs almost always include the full request URL with query string. Bodies are not logged by default and often avoided for size/security reasons. So, it's better for routing and infrastructure for logging is like if you just have a couple of simple KV pairs, throw it in as query parameter if it's not like huge amounts of data or if it's not like something sensitive, go for it. Just, select whatever floats your boat. Yeah, just feel good, bro. um, Efficiency for simple modifiers, query params are lightweight and easily included in a URL for simple modifiers. Setting a body for every read would add parsing overhead and complexity when you just want something like question mark page equals two. So yeah, right, because reading a body just requires parsing, which is past parsing the URL. So it's just an additional step, which can add up over like tens of thousands of twenties of thousands of hundreds of thousands of millions of billions of requests, you know. Shit adds up. Visibility and debugging, that one makes sense. It's like easier to just debug a URL versus the body, which is a bit it's hidden. It needs to be manually inspected usually, for like a body for a particular thing. Um when a body is used for queries anyway, like if it's too complex or exceeds URL length limits, some use post/search with a JSON body. It's a pragmatic deviation because query strings would be unwieldy, but it's usually documented explicitly as a search instead of a pure RESTful get because it breaks the conventional safe get pattern. So essentially, you can do that, but if you're doing that, the right thing to do would be to just not use the get operation, use the post operation, so that's fine. I think that made a lot of sense to me once I read that. I'm like, oh, okay, so that's why the difference. It's a small thing. It's something I never actually questioned before, and today I was just like, why? And that's an important thing. You should never take anything for granted. Always ask why. That's like a beautiful aspect of all this, right? Like shit happens for a reason. Life happens for a reason. Getting philosophical here about, faith and your place in the universe, but things happen for a reason. At least that's what I believe. Oh man, things happen for a reason. That'd be another good name for this video, but I'm gonna stick with please like and subscribe. Because it's funny to me. Anyways, I think that's it for today, guys. Thank you so much for watching. I think this video is quite a bit longer than I actually expected it to go down, so Enjoy.